Ever wondered how engineers analyze and design complex impedance matching networks? Well, it's all thanks to a handy tool called the Smith chart. This graphical tool, invented by Philip H. Smith in the 1930s, has become an indispensable asset for electrical engineers and telecommunications experts. Imagine a polar plot. This is what the Smith chart essentially is, a complex impedance plane. It sports two axes, a real or horizontal axis representing resistance, and an imaginary or vertical axis representing reactance. The chart is usually carved into concentric circles denoting constant resistance values and radial lines indicating constant reactance values. The Smith chart operates on the principle of normalized impedance. This is a process where impedance values are scaled or normalized relative to a characteristic impedance. The characteristic impedance can be any value, but 50 or 75 ohms are typically used depending on the specific application. With the Smith chart at their disposal, engineers can nimbly analyze and tweak impedance values to match a desired load impedance with a source impedance. It also serves to design impedance matching networks, such as transmission lines, stubs, or quarter wavelength transformers. But what makes the Smith chart truly remarkable are its key features. First off, it can calculate the reflection coefficient of a given impedance. This coefficient shows the amount of power reflected from an impedance mismatch. By locating the normalized impedance on the Smith chart, the corresponding reflection coefficient becomes apparent. Secondly, the Smith chart enables engineers to perform various impedance transformations to achieve impedance matching. By leveraging the chart's scaling and rotation properties, it's possible to decipher the correct values for reactive components like capacitors or inductors to reach a desired impedance match. And finally, the Smith chart facilitates operations such as calculating the input impedance of transmission lines, ascertaining the voltage standing wave ratio, VSWR, determining an amplifier's stability and analyzing the behavior of filters. Beyond its analytical prowess, the Smith chart is also a visual aid. It helps visualize impedance characteristics like standing wave patterns and impedance circles. These visual aids are crucial for understanding and predicting the behavior of circuit elements and transmission lines. So there you have it. The Smith chart, a powerful tool that simplifies impedance calculations and provides insights into the behavior of complex impedances within the RF frequency range. It's not just about crunching numbers, but about understanding, designing, and optimizing impedance matching networks and microwave circuits. Now that's something to marvel at.